Get going. Good morning, everybody. Welcome to another exciting morning of chemistry, Chem 1211, with your host, me, Dr. White. I better fix these up. And hold on, that's better. And it's a fun morning today, and it'll be a quick morning too. All right, a couple important things. One, I think most of you are aware of the fact that Blackboard had serious problems yesterday. It was down from about 11:30 until about 6:30, 7 o'clock at night. If you were one of those who emailed me your test because you couldn't upload it, relax, I got it. But to help me out, it'll make my life a lot easier. Could you please upload it to the assignment area of Blackboard by tomorrow, say about 1 p.m. Because it was down, I didn't get to start grading tests. I got some stuff today, but I will guarantee by Sunday, 1 p.m., I will have the grades for test number 2 posted in Blackboard. Even if I have to stay up all night Saturday night, I hope I don't. But anyways, I'll get it done. Trust me, I will. When I set a deadline, I meet them. That's just a personal thing. Okay. Another thing, lab. Thank you, Justin. Any good music? Or are you in your car? So anyways.
Yeah, I'm in my car.
I had someone last semester come to my office hour, and he worked in a private ambulance, and he just dropped someone off at the hospital. He had a break, and he called in. Where are you? Oh, I'm in an ambulance. Are you all right? No, I'm EMT. All right. Anyways, make sure you look out for that tree. But meanwhile, all right, I graded lab 7. I posted it up. I would have done it earlier, but there was no Blackboard available yesterday. For lab 7, common mistakes students made. One, if you got the magnesium oxide formula wrong because you messed up your calculations, I took off 2 total points. And by the way, it's MgO, Mg1O1. Either one would be correct. Next, the 2 questions at the end were each worth 1 point. I asked what was the dull material or substance on the outside of the magnesium metal, and that's magnesium oxide. If you put oxygen, that's wrong, because oxygen is O2 and you don't see it. And finally, the last question on that lab asked, would a student in Amsterdam get the same results as you do? Of course. Think about it. Is water in Chicagoland different from water in Amsterdam, chemical formula, or you pick a spot in the world in our universe? How about the ice on Mars? I think they said they found ice, or what is it, Saturn? I think there are ice moons out there, at least they say so in science fiction. But anyways, water is water, so magnesium oxide is going to be a magnesium oxide. Those questions were 1 point each. All right, now, another thing, and I've talked to one of your colleagues about this the other night in my office hour, and I've seen this in the past, was the fact that if you haven't noticed, there's a slight generation gap between me and you. I'm just a little bit older than you guys. Yeah, right. Like a little bit. I don't think I can. But because that generation gap the last couple of years, I found out something very sad. Yes, sad. And that is, a lot of you don't know about good music, good books, or good movies. Oy vey, you just don't know the good stuff. So, to be a nice person, and I am, if you look at Blackboard, let's look at it. Everybody see Blackboard on their screen? Those who aren't. All right, we're in motion. You'll see over on this corner, there's a new thing right underneath Dr. White's YouTube channels. you'll see Dr. White's favorite music, movies, and books. If you click on that, you'll open this, and let's open it up. And here I have some of my favorite. I like all types of music. As you can tell, Bach, the harpsichord music on Deutsche Grammophon by Trevor Pinnock is awesome. I've had it for many, many years. I love Deep Purple. Uh, for those of you, a lot of these non-classical are in YouTube. Del Shannon, Runaway is a favorite. Jefferson Airplane, Go Ask Alice. I heard Gracie Slick do that live in Chicago in concert. My all-time favorite is Fire. I heard Jimi Hendrix do that live. For those of you who don't know country music, yes, I used to play, not that good, the banjo, and the Ballad of Jet Clampett by Lester Flatt and Earl Scruggs is a classic. That was the theme song for the Beverly Hillbillies, but Foggy Mountain Breakdown is better. And Moody Blues, I saw live twice in Chicago. I would like to have seen Pink Floyd. I also like Time from Pink Floyd. I didn't put the Beatles down because there are a lot I like. I think Sgt. Pepper's Lonely Heart Club album, I like a lot of stuff on there. I'm not going to ruin your day and start singing Yellow Submarine. But anyways, a couple you may not be familiar with. I got to look at some of your faces now because I'm going to watch you. Nervous Norvis. That was the first record my parents bought for me. It was a 45. One side was Ape Call, the other was the Wild Dogs of Kentucky, and I still love them. It'll make your day. And yes, that's on YouTube. I think everything's on YouTube except my high school graduation. Maybe the day I was born too. I'll have to look for it. No, I don't think so. But anyways, and another one of my favorite, all these are my favorite, but real favorite, which you probably never, the Chantays, or I think that's how you pronounce it, Pipeline, that's mine. And the Electric Prunes had only one hit, and I loved it. I Had Too Much to Dream, and also was called I Had Too Much to Dream Last Night. And my two all-time favorite songs are Jimi Hendrix Fire and Shapes of Things by the Yardbirds. That's awesome. Also, Mr. You're a Better Man Than I. Train Kept the Rolling is good. I didn't put down there, I should have, Smokestack Lightning. Now, when we come to movies, funny movies, if you haven't seen Blazing Saddles, you should. And if you haven't seen an older movie that's almost as funny, that's Duck Soup by the Marx Brothers, see it. That was made in 1930s, and it's awesome. Now, on this list, can you guess where's my all-time favorite movie? Yes, I'm into Kung Fu, Enter the Dragon, and Five Fingers of Death is a pretty bloody good fight movie, Kung Fu movie. But my all-time favorite is Forbidden Planet. I think I have 4 different copies of different quality, and I finally got a Blu-ray a couple years ago. And I first saw that movie when I was 8. My sister took me to the Nordtown Theater, which I probably is not there, by the corner of Devon and Western in Chicago, because we lived around there. And I've seen it so many times, I think I can do every line in that movie by heart. And if you've never seen the original Time Machine, not the new remake, which stunk, but the one from 1950s, that was a good one. And another one, Seven Samurai, which is a Japanese film that they, how should I put this politely? They copied the whole theme sort of and changed it a little to make The Magnificent Seven, which is a classic movie, but this is a better one. Sink the Bismarck I like, and all these I like. And finally, some books. You should read the Dune trilogy is great. The Foundation trilogy by Isaac Asimov is fantastic. Harry Potter series, about right after the second book came out, a friend of mine who taught English at Elgin Community College said, "You've got to read this book." What? Well, it's this thing about a magical world. It's a children's book. I'm not a child. Well, you got to read it. And finally, 6 months later, to get her off my back, I read the first one, and I was hooked ever since. Of this list, it's a toss-up. Shogun is an awesome book, and Foundation trilogy by Asimov. I should have put on there I, Robot, which they made into an awful movie, and it's a great short story book, and the rest of the robots by Asimov. And those are all things you're missing in your life, and you shouldn't be. So enjoy. And that way I can, how should I say this politely, teach you about the good stuff in life. All right, let's get to chemistry. Now, I can't ask you to, let's do the problem set, because you just had a test on Wednesday. Also, before I forget, and I probably would have, I'd like to wish all of you a fantastic spring break. Just think of it. You won't see me for about a week or so, unless you look at my videos, in case you're getting Dr. White withdrawal symptoms. I doubt that. But if you're going away, don't forget to send me an email, having a great time, wish you were here. Or you can send me an email, having a great time, glad you're not here. Quick story behind that. When I worked for two Dutch companies, Anglo-Dutch companies, I would go to Europe at least 4, maybe more times a year, and I'd be there for at least 2 to 4 weeks at a crack. And I'd be in different cities throughout that time. Like one trip, I'd get to Amsterdam. From there, I'd go to Den Haag, The Hague in Netherlands. Then I'd go to maybe Brussels. Then I'd back to Amsterdam, and then over to Manchester, and possibly even Liverpool in England. And each city, I had a list of about 35, 40 people, my immediate family and people I was very close friends with, and also people I worked with that I would send postcards from each city to. And one city I'd write on the postcard, having a great time, wish you were here. And the next city, having a great time, I'm glad you're not here. And that's the story behind Dr. White's postcards. And they all got delivered from Europe back to the United States, and people love getting them. All right, let's talk about today's lab, because that's all we're going to do today. And then I'm going to let you out early today so you can start your spring break on time or early. And that is today's lab. Today's lab deals with the ideal gas law. And the ideal gas law is PV equal nRT. And P is pressure in atmospheres. V is volume in liters. N equals moles. I hope you all know that's chemist counting unit. And there are 4 other answers you could have put for that question on test number 2. R is 0.0821 for these units above: atmospheres, liters, moles, Kelvin. And finally, T is temperature in Kelvin. And this is a law. And a law in chemistry, or in science and chemistry, means it's always true. Well, guess what? What if I'm lying to you about this? Maybe it's not a law. How do you know? Well, everything I've taught you this semester and will teach you this semester, chemists have gone into the laboratory and done experiments to prove that's a fact. One company I used to, a big slam in a meeting, I heard someone say, by the way, is that a fact and the truth too? Yeah, but anyways, but the question is, how do you prove it's a law, that it's really true? You go into the lab. And today's experiment or laboratory you'll be doing, there are two parts of it. The first part, I've already done the data. If we were at COD face-to-face, you would be doing the exact experiment I have or similar, is by doing a chemical reaction and knowing the coefficients of a balanced chemical equation gives you molar ratios. You can determine if I started with this amount and I made this gas, how many moles did I make? And they should be the same if the ideal gas law is true. And you're going to have to find that out. Let's take a look at today's lab. Thumbs up, people. Do you see the lab on the screen? Thank you. All right. Like I said, the ideal gas law, PV equal nRT, here are the units. And today's lab, you'll determine if it's true. How? By doing a chemical reaction and determining the volume of a gas at a certain temperature and pressure. And from that, you can determine the number of moles. Now, the reaction you're going to be using is this one. Magnesium reacts with hydrochloric acid, HCl, to make magnesium chloride and hydrogen, H2. And this is a gas, which the arrow up shows you. And if you notice the coefficients, 1 mole of magnesium makes 1 mole of hydrogen. I even have it written down here. And from that, you can calculate N using PV equal nRT. And the moles of magnesium you start here should be equal to the moles determined by PV equal nRT of the hydrogen here. And that's what you're going to be doing. Let me show you a video, or YouTube actually. Now, parts of this we would do differently at COD, like instead of the wire paper clip or metal clip, we found a better way to hold the magnesium in the tube. We use a slightly different tube, but essentially the same. Okay.
It's not that easy, but Grammarly can have
3,
adequately correct.
2.
First thing you do in the experiment is measure the mass of the magnesium strip. There's an alternate way to do this that gives you more significant figures that's in the description. But for this particular experiment, we're really not going for intense precision anyways.
We do.
Magnesium in place, you need to kind of use a piece of copper wire, and you're going to put that through your 1-hole rubber stopper so it can kind of move in and out, but it's going to be stuck. And then you're going to put the magnesium in with the copper, but you need it to be held in place because if it gets released,
we do a better way.
It'll float up to the top and it won't fully react. And so this can be pretty challenging. You have to be careful because you don't want to get a splinter from the magnesium, and that also just kind of give that a squeeze, and that'll hopefully hold it where it's not going to, as the bubbles go, rise to the top. Now let's go ahead and look at the Udeometer. So the Udeometer is open on one end and closed on the other.
We use a burette, but the same
pour your
thing.
Hydrochloric acid in. It's about 10 milliliters. And you want to use somewhere 3 molar to 6 molar hydrochloric. And it's also really important that you add food color to the hydrochloric acid. We don't add food color. See it as you're doing the reaction. So I added blue food coloring, and the hydrochloric acid turned that into yellow somehow. So this has had a little bit of red added to give us an orangish color. And then you're going to pour just regular tap water in. And you want to pour it in where you pour it very slowly. And so to do that, you need to tip the Udeometer, because what you don't want to do is you don't want the water and the hydrochloric acid to mix very much. You want it to kind of run down the side and form layers. And at the beginning, that's not going to work well. That's fine. But by the point you get to midway up the Udeometer, short on water, so now we're going to add just a little bit, and we're going to fill it all the way to the top so it's going to flood over, but it's not the hydrochloric acid at the top because it hasn't had a chance to mix evenly. And so we're just going to let the water flood out of the top, and we're going to seal that with our one-hole stopper with a copper wire and the magnesium sealed inside. We have the hydrochloric acid at the bottom, water at the top with the stopper, and we're now going to flip that upside down. And as the hydrochloric acid, you can see that red color kind of moving down towards the magnesium. And what happens is, as that hydrochloric acid slowly mixes, it ends up reaching the point where it gets to the magnesium. And when that happens, you start to see bubbling. And so as those bubbles go to the top, it pushes the hydrochloric acid mixture even further down, and the reaction continues to happen. And since you have an excess of hydrochloric acid, you can see this is going to actually start to react faster and faster. So right now we're at the beginning, you can see a little tiny bit of bubbling where the magnesium ribbon is, but that bubbling is going to pick up more and more and more as you see that red color shift down towards the bottom.
Those bubbles are hydrogen gas.
So now we're going to go ahead and speed up the video so this doesn't take so long because it's a long stretch for this reaction to happen here. But we're going to flip back and forth where you can see the bubbling and you can see what's going on at the top as the bubbles push that water and hydrochloric acid as that gas is collecting. So the reaction has slowed considerably. We're not quite done yet, but now if we take a glimpse of where we are, we can start to see if we're getting to the end. So currently we're between 62 and 64. It looks like we're right around 63 milliliters right now. So we're going to let this react a little more and see if that changes. So it's now about 6 minutes later. And we've definitely changed from 63 right now. It looks like it's very close to 64. So when we look against the backdrop, it looks like it's just not quite to 64. So maybe 63.8 milliliters of gas that we've collected. Keeping in mind that the pressure is not even here because we haven't had the water levels evened out. And water temperature about 21.5 degrees.
All right, when you do that in the lab, you get about the same thing. We have a better system for holding the magnesium, and it takes about 10 minutes in the lab. And in real life chemistry, when you're doing an experiment like that, you usually do at least 2 runs to make sure the data is the same. For this lab, since I'm giving you the data, you only have to do 1 run. Now, let's look at the lab. Now, here are the steps they did. And here's the weight of the magnesium strip. Let me just check. Everybody see the lab? Thank you. And here's the initial volume of the burette. And here's the final volume. And the difference, 3 minus 2, which is the number 4, is how the volume of the gas collected. Now, room temperature, and I also assume the water temperature, is 22 degrees C, and the atmospheric pressure in the room. Yes, in the labs at COD, we do have barometers to measure this, is 755 torr. Now, I have here, first of all, calculate the moles of magnesium. How do you do that? Well, I have it here, but here we have grams of magnesium? Times moles of magnesium divided by the atomic weight in grams of magnesium equals moles of magnesium, which you put there. Now, calculate the theoretical. Well, that's the same number here, because theoretical, 1 mole of magnesium makes 1 mole of gas, hydrogen. See, I even showed to you. Am I nice or what? Now, calculate the temperature in Kelvin. Look at the temperature and above, 22, and use this formula, Kelvin equals degrees C plus 273. Now, atmospheres, I'm going to let you try and figure this out on your own. Remember, 760 torr equal 1 atmosphere. Use your good buddy, your good friend, your analysis. Now, the temperature in the hydrogen in Kelvin is the same as the room temperature. And the pressure in atmospheres, well, you just calculated it up here, so you can put that. Now, volume in PV equal nRT is in liters. All the problems I give you on a test, I'll use liters, but in the lab, we measure milliliters. So you have to take number 4 and divide it by 1,000, and that's how you convert milliliters to liters. And you have that. Now, if you look at number 4, you have the atmosphere. Well, let's say number 5, you have the temperature of the hydrogen gas in Kelvin. Number 6, or actually this right here, which I call number 9, you have temperature of hydrogen gas. Number 10 here, you have the pressure in atmospheres of the hydrogen gas. Here, number 7, or I should say number 11, in part 7, you have the liters. Therefore, you can use this, solve for N, and PV divided by RT, and will give you N. And this should be the same as the theoretical amount in number 2, i.e. 6. If they are, guess what? You prove PV equal nRT. Now, let me define the same. With the equipment you have at COD, you're not going to get the exact number. No way. I couldn't get the exact number, but it'll be very close. So what do I mean by very close? Well, if you get, for one, say 0.150, and the other you get 0.137, in my book, that's pretty close, and you proved it. Now, if you got 0.150 and you got 275, no, that's not close. So I think you can, that shouldn't happen. Oop, I gave it away. Bad, Dr. White. Anyways, that's the first part. Now, the second part, you people paid for Beyond Lab Z. So let's use it and have some fun. And they have a nice gas lab to do it. Let me go to my internet connection or browser. Let me log in. Everybody see Beyond Lab Z? Thank you. Click on chemistry, the higher ed one. And this is in the instructions in the lab. So if you want to take notes, you can, or you can also look at the video. And does everybody see gases on top? Okay, I'm glad I asked. Now do you see gases? Click on gases, the balloon. All right, everybody see the tanks over here? You're welcome. Thanks, you're welcome. Oh, it's Bad Humor Friday. I'll never use that again. Now, important things you should be doing. One, this is in the instructions. See over here where it says real gases underneath the red book? Click on ideal gases. All right, you're gonna want 6. But before we do that, you're gonna click on the stock room and then see the little black lift equipment where it says above balloon? Click on that. Whoa, a lot of noise. And you'll see this box and click on Return Lab. Wow. It sounds like the game Mist, if anybody ever played that. You want to use ideal gas 6. See where it says over here, ideal gas 6. Click on that. Now, this is a regulator. Most of you probably haven't used these. Dr. White has. And what it is a way of controlling the pressure that an amount of gas you're going to put into something. Now, in real life, you would turn this knob clockwise or counterclockwise to adjust the pressure in these gauges. This tells you what the pressure is in the pump in the tank, and this is the pressure you're going to use to fill a balloon. So for this lab, click on the, I guess it's a brown arrow or orange, my colors, and click till you get to 400. Now, open the valve. Oh, look what's happening. Is that cool? Let's stop. Let's click on this. Now, these are your gauges, and you can do different units, as you can see here. Have this one liters. This one I have in atmospheres. Temperature will do 2 different ones. Let's do a 24. Let's bring this a little bit more to about, we can leave it like this, around 4 liters. Now, in the lab, I'm going to ask you to raise the temperature. First, record all these, and notice they were nice enough to calculate moles. Now, everybody see the lab now? Thank you. I'm going to ask you to do 2 runs. In the first run, what we just did is fill the balloon, and then right here, put in from those gauges, what's the volume in liters, what's the pressure in atmospheres, temperatures, degrees C, and moles. And then if you look up here, after you do that, run number 1, step 13, go to 14, raise the temperature to anything above 100 degrees. Well, let's do that. And you can do 2 ways. You can either, everybody see the box now? Thank you. You can either increase it this way, which gets you to there, or you can go and click on that, and let's make it a 10. I'll do it we'll take it above. And if you notice anything above 100 like this, the balloon got larger. Now, if you notice, you have new values: volume, pressure, temperature, and moles. And that's the data you put in here for run 2. And before we go any further, and what you'll do is calculate. Now, here I have degrees C. You got to change that to Kelvin. Make sure you do that. And for here, use PV divided by RT to get the moles calculated from here. And then take the moles from this table right here And if they did their job right, these should be the same. I'm not going to tell you if they did or not. Now, one more thing, I thought you should have some fun. After you've got your run 2 values down in table 1, raise the temperature above 200. Well, yeah, I'm going to give it away, but you can do it on your cell own too. Watch what happens to the balloon. And if you have young kids, show them that. They'll love it. And by the way, if you ever want to do it again, hit reset and you fill the balloon again. And that's today's lab. Oh, one other thing, you know I'm going to have it there. There are some questions for you to answer. And that's today's lab. I see Kelly has a question. Go for it.
Not surprising, I have a question.
By the way, still true and it'll always be true. There's no such thing as a dumb question in my class, and there's no limit per student how many questions you can ask in a day, an hour, or in a semester.
Thank you. When on the lab, the chart that you showed us that was like test number 1 or experiment number 1 and experiment number 2, how do you do the first part? Where do you get the first part from? I don't know if I'm explaining this right.
Hold on, let me show my face.
Yeah, the Beyond Labs.
Beyond Lab. When you first fill the balloon, you'll remember how I showed you initial numbers before the balloon got bigger, and then I said, look at the numbers. That's yes. Where you get it. Now, let's see if I did my job right. Wrong part. All right. See what I say? Open the valve and click the valve. All right. Click on the box. Check and after you fill it, you know, the first time you fill the balloon, about 4 liters. Do you want me to do it again for you?
I just didn't understand where it says run 1. Yeah, where it says table 2.
When you initially fill the balloon the first time, when you fill it up before you change the temperature, record the values there. Here, watch out, watch.
I understand that. I didn't understand table 2.
Oh, table 2, I'm sorry. I thought you were talking about run 1. Table 2 is for calculated value for each run. You take the numbers here in run 1 and you calculate the moles. You do this equation. And same thing for run 2. And that's still calculated. The moles over here would come from these values that he actually got from the gauges. Is that better?
Yes. I didn't read it correctly, but you explained it better. Thank you.
Hold on. There's no such thing as a dumb question in my world. If you're not sure, ask, and you did, and now you are. And I really mean that. By the way, I have a question. Justin, where are we driving? Anywhere neat?
We're on our way to West Palm Beach. Yeah, West Palm Beach.
Where are you? What town are you near?
We're in Georgia right now. We just drove through Atlanta.
God. Don't try and vote. They'll throw you in jail. All right, we're in Georgia. Everybody, this is a multi-state course. Dr. White is known throughout the United States. I won't sing any of the Georgia songs I know. Make sure you're careful if you see any redneck sheriffs. Actually, that happened in North Carolina. I was going to a company out in the middle of nowhere with our salesman. He got lost. And all right, hold on. I'm going to let everybody go, and then I'll do a Dr. White story. This is a good one. All right. Any other questions, lab, before I let anybody who wants to go, and I'll do another Dr. White story that I'll cut out of the video, but it's really cool. Oh, no, it's interesting. Anything else? Looking
I have a question.
I do questions. Whoever.
I have a question. So when is this lab due?
Oh, that's a good one. Now, all right. When is this lab due? Guess what? Not next week. It's spring break. Even people in Georgia, it's spring break. By the way, have a good time, but don't forget to wear your mask. All right. But anyways, this lab is due 2 weeks from today. Because next week is spring break and you don't have any classes. So I can't make you turn in something when there's no school. That's bad. And anyways, look at the due date in Blackboard. You'll see it's 2 weeks from today, not next week, but the following week. Okay, and that's an excellent question. Thank you. Other questions? Going once, going twice. Well, it's time for me to do my world famous goodbye. But before I do that, I'll wish everybody a fantastic spring break, even those of us who are going out of town having too good of a time. But anyways, I'll wish everybody a great spring break. For those of you who are celebrating Passover, have a happy Passover. For those of you who are celebrating Easter, have a happy Easter. For those of you who don't celebrate those, have a happy spring break. I think I got everybody. And with that, don't forget, I'm going to have a good story after I say goodbye. I'm going to do my world famous goodbye, at least multi-state famous goodbye now. And that is, Gang Gesund. Goodbye, be healthy, and I'll see you in about a week or so, unless you want to watch my videos.